Hi Year 12 Maths General students. I've just put together a little topic test for Unit 3 topic of bivariate data. So they just contain some practice, simple familiar, complex familiar and complex unfamiliar questions. So I've got 8 questions in this particular test. So we're going to go through each question and work through the answers, so you can see how you're going with the content on bivariate data. What I did was find all the questions that I could from the sample assessment released by QCAA and put together questions that were like those simple familiar, complex familiar and complex unfamiliar questions they released. Okay, as we go through these questions, we'll read through the question and I'll get you to press pause, have a go at the question, and then I'll pop up my worked answer and hopefully you experience success as we go through. Okay, question 1, simple familiar question. We've got a sample of people attending Supernova and they were surveyed on their favourite superhero. Of the 200 people surveyed, 18 females as well as 32 males preferred Superman. Of the remaining females, 87 picked Batman as their favourite superhero, and 24 of the 88 males surveyed chose Wonder Woman. So you've been given enough information in there to complete part A, where you've got to put together a two-way table using gender as your explanatory variable. So part of this is you trying to recall which one goes to make up your columns. Is it your response or your explanatory? And which one goes to make up your rows? Okay, and the second part of the question just wants us to calculate the percentage of women from the survey who prefer Wonder Woman as their preferred superhero. Okay, press pause and have a crack. How did you go? So hopefully you recalled that explanatory variable usually goes at the top here and the response variable goes along the side here. Okay, I popped in everything we were told in blue, and then using some basic addition and subtraction, I worked out the missing elements within the two-way table in red there. Before you move on, just make sure you're always checking your totals add up. And moving on to part B, percentage females who preferred Wonder Woman. That's 7 out of 112. Converted to a percentage is 6.25%. Moving on to question 2, another simple familiar question. We've got a scatter plot here and you have to describe the association you're observing in terms of strength, direction and form. So have a go and we'll check in. Okay, in terms of strength, it looks pretty moderate. If I was to put in a line of best fit there, you could see that the points don't fit it really well. I wouldn't say it's strong, I would say it would be a moderate strength. The direction's positive from left to right. You can see this curve shape of the trend line, which you describe as non-linear. Okay, moving on to question 3, which is another simple familiar question. We've got the height and diameter of tree trunks within a forest that was recorded. We've been given a scatter plot below showing the height of each tree on the x-axis and the diameter of the tree's trunk on the y-axis. You've been asked to identify the explanatory and response variables. Then from there, you're given some extra data to plot onto the scatter plot. And the last part is from the list of values below, give the most appropriate correlation coefficient to represent the association you're observing between the height of the tree and its diameter. Press pause, have a go, and we'll check in with my sample answer shortly. For part A, Because the height is on the x-axis, that means that it's the explanatory variable, and because the diameter is on the y-axis, that means it's the response variable. Even if you couldn't draw the points on because you don't have the copy of the graph, hopefully you envisioned the 250 point going here and the second point 930 about here for a 10.6 diameter. For part C, you can see from the graph it has a negative trend, so you'd eliminate the positive values there. It doesn't have a perfect fit, so it's not -1. It doesn't have a really scattered fit, so it's not -0.3. So I would select -0.7 as your R value, your correlation coefficient. For question 4, I made it contain both simple familiar and complex familiar parts. Part A, C, and D are aimed to be simple familiar, and part B is complex familiar. Part B is quite complicated process because we're using this correlation coefficient formula from your formula sheet, which if we pop over to the formula sheet and we go down what we're seeing here, it's on the second page and we're looking at using this correlation coefficient formula. Let's start by actually reading through what the question wants us to do in question 4. The following data is reported by Queensland Health on the life expectancy, so expected remaining years of life for females at certain ages. You've been given a table of data here. Also to the side here, you've been given a mean for your X or explanatory values, which are your age, and its sample standard deviation. And you've been given the mean for your Y or response variable and its sample standard deviation. And you have to use these values, as you can see within this formula on the formula sheet, to calculate the value of R. If you're really unsure on how to do part B, at least have a go at parts A, C, and D. So you experience some success and you're maximizing, if this was an exam question, the marks you could earn. Alright, press pause and have a go. Okay, normally I'd use Excel to construct a scatter plot, but we don't have that luxury in exam situations. So by hand, you can see I've put the age on the x-axis because I know that's the explanatory variable. The life expectancy we've put on the y-axis because that's your response variable. Plotted the points. That looks very strongly linear, a negative linear trend. Moving on to part B, this is where we get to use that super awesome formula from the formula sheet. So the easiest way to deal with that formula is just to substitute everything that we can really simply into that final equation. So to do that, the easiest way is to set up a table of values, which we can then use to find these parts of the formula, making the whole process a lot easier. So we need to add up the product of the individual differences between the explanatory values and the mean divided by the sample, and each of the differences between the response variables and the response variable mean divided by its sample standard deviation. Okay, so I've listed out the values I've been given. I know there's 9 values altogether. So here I've just listed the column of given ages from the raw data table. Okay, in this next column, I've put the individual age minus the mean age, which was 20. Okay, so for example, if my age was 0 and I'm minusing the mean age of 20, I have minus 20. Its response variable is 84.6, as you can see here. I take that value and I minus its mean of 65.01. So 84.6 minus 65.01 is 19.59. And then I'm interested in the product of these two columns. Because eventually I want to add up all of those products. So you work those through, and then eventually remember that funny looking E sigma means the sum of. So I want the sum of these products, and when I add up this whole column, I end up with minus 1476.5. Okay, so if my n value is 9, I know my sample standard deviation values. I now know the sum of the differences between the response and explanatory variables and their means. So now it's just a matter of subbing all of that information into that horrible looking formula. And if I evaluate things one step at a time, I should end up with an R value of minus 0.998, and that's rounded. When I check it on my calculator, I get an R value of minus 0.999. For those that need a quick reminder on how to input all of that, you go to Mode, select to Stat, 2a plus bx, and then enter in all of your data. So enter in the number and press equals, and then go across to your y column and enter in all of those values. Once you've entered in all your values, just do a quick recheck that you've entered them all in correctly. Press your AC. Shift 1 brings you up your statistical functions on your calculator. Select option 5, reg, and option 3 gives you your correlation coefficient, and press equals. There we go. Okay, from that correlation coefficient value, we can establish that it's a very strong association because it's very close to 1, and it's in a negative direction because the correlation coefficient has a negative value, and it's linear in form from the scatter plot. With questions like these, just strongly encourage you to always have a go at the question, even though you might find parts B really difficult. At least try the easier, simple, familiar parts to maximize your marks for the question. Question 5 again has simple familiar and complex familiar components. So we've got data collected from a controlled experiment recording distance travelled by a ball in meters before hitting the ground, and the force of the ball was initially hit with F in newtons, so it's force in newtons. Your job is to, from that data, identify your explanatory and response variables, calculate the correlation coefficient to 3 decimal places, and interpret this in the context of the data. And the complex familiar part is C, where the scientists who ran the experiment stated it's evident that increasing the force hitting the ball causes the distance travelled by the ball to increase. Is his statement correct? Justify your decision by concluding if there's a significant association between force and distances using percentages. Again, have a go at the question and we'll check in with a sample answer from me. Checking in, part A, your explanatory variable is your force in newtons, and your response variable is your distance in meters. For part B, this is where you'll need your calculator. Put in your values like you've shown before. Check that they're all correct. Clear it. Shift 1 to access your stat functions. 5 for regression, and option 3 for your correlation coefficient. And that gives you 0.96857, which we just round to 0.969 for our answer. It's a positive value. It's fairly close to 1. So that supports a positive association or correlation between the force the ball was hit with and the distance the ball travels. For part C, the question alludes to needing percentages. So we know we can get percentages from the R² value or coefficient of determination. So I square that correlation coefficient, I get 0.94. Convert it to a percentage is 94%. So then we can go on to say, yes, his statement's supported by the data because 94% of the variation in distance travelled by the ball can be explained by the force the ball is hit with. And if you're a science person, you could probably also mention that other factors can cause an effect on the distance travelled, which might include things like wind resistance, gravity, friction. Question 6, a complex familiar question. We've got a coach comparing resting pulse and number of weeks of training for 9 runners. You're given the raw data there, and you have to write a conclusion on the explanatory power of weeks training on the resting pulse of runners based on your interpretation of the data. Okay, so based on the wording of that, it's alluding to the fact that you need to use that coefficient of determination and explanatory power of weeks training, so that's obviously your explanatory variable, and resting pulse of runners is your response variable. Okay, give it a shot and we'll check. Okay, because I need to calculate my correlation coefficient, I'll enter my data into my calculator, check that it's all correct, clear it, shift 1 to access my stat functions, reg, option 3, and I get negative 0.845-ish. And that supports a strong negative association. If I square that value, I end up with my coefficient of determination of 0.713, which converted to a percentage is 71.3%. So from there, I can conclude that there appears to be a strong negative association between running training and lower resting pulse. So in other words, an increase in training decreases your resting pulse. The coach could conclude that 71.3% of the variation seen in resting pulse rates can be explained by the number of weeks trained by runners. And any PT would probably also tell you that other factors like genetics, diet, lifestyle habits could be other causal explanations. Question 7 I made into a complex unfamiliar type question. So we've got a real estate agency, Topsell, publishing results of its sales for the year, boasting that its sales were increasing significantly each year since it opened its doors. You've been given the raw data here, and as part of the advertising, they also published the following line graph to display their trend claims. You have to evaluate the reasonableness of Topsell's claim and give mathematical reasoning for your conclusion. So have a think about what you could do to look into that, and we'll check in with your answer shortly. Okay, I would probably start off by processing the data. In doing that, I would look at the values and go, okay, do they all look like they support the same trend? Are there any possible outliers? And we have a look here in the fourth year. If I plot those points on the graph, you can see that this fourth year is a possible outlier, and if so, it's pulling the trend line up. So your trend line, if you think about it, probably would look more like that if that possible outlier wasn't there. Going on to evaluating the reasonableness of their claim, I'd just say something like plotting the points on the graph shows that the data from the fourth year is most likely an outlier, which would inflate the sales averages, affecting the regression line fit to the data by pulling it up. You could then prove that using your calculator. You could show the regression line in that y equals bx plus a format. Enter in your data, check that it's all correct. Then access your statistical functions. If you go into option 5, regression, you can pop out your y-intercept, the a value, your slope or b value, option 2. That will give you a regression line including the potential outlier of y equals 168x plus 1318.67. So remember, the y is your response variable, so that's the value of sales. Your b value is going to be your slope, which is the point of interest for us. So they're saying sales are increasing by $168,000 per year since opening. If you then find the R correlation coefficient, that's 0.523-ish, which supports a moderate positive association between your sales and each year after opening. Square that, you get 0.273, which shows a 27.3% of the variation in sales can be explained by the variation in each year that passes, which isn't very significant or strong. If you then remove the outlier from your data, so you can go back to option 2. If you go down and just press delete, it'll delete that one. Okay, and again, you can pop out the regression line, so the new y-intercept value, the new slope value, which is of interest to us, and the new R value, so 0.9-ish. Okay, so the regression line becomes y equals 123.79x plus 1236.51. So interestingly, the slope value becomes a smaller value of 123,790 sales per year since opening. You can see the correlation coefficient increased to 0.9, which does support a strong positive association between sales and the year that passes after opening. If you square that, you get a coefficient of determination of 0.81, which then improves the correlation of 81.1% of their variation in sales being explained by each year that passes after opening. After all that, I would probably come to the conclusion that top sales claim is flawed and possibly inflated based on the fourth year of sales being much higher than the other years. Okay, last question. Question 8, another complex unfamiliar. You've got a table there showing you the sales of new motor vehicles in Queensland 2019. And we have, looks like type of vehicle is your explanatory variable because it's on the top there, and age category is along the side, so that's your response variable. You have to determine any patterns that suggest the presence of an association between a person's age in Queensland and the type of vehicle purchased, providing reasons for your conclusion. Press pause, have a go at the question, and we'll compare your answer to my sample answer. Alright, so when we're comparing categorical data to look for association here, we know that we need to convert everything into percentages. So if I add up the column totals I'm going to take each row as a percentage of that column total. So, for example, for young people that have utes, I'd do 1,546 divided by 10,351, and I'd get 14.8%. Given that I've worked out all of those percentages, you'd then go across each of the age categories and see which ones stand out. So, for example, for the young one, I can't really see any standout percentage there. For mature age, this 52.9% purchases of utes stands out to me. For middle age, the sports vehicles at 45.3% stands out. For older age drivers, the sedan at 47.3% stands out. So from the 41,721 vehicles sold, there does appear to be an association between a person's age, which is your response variable, and the type of vehicle purchased. I listed out those 3 examples. For the young age, probably because of their financial restrictions at that age, they don't care which vehicle they buy. But overall, I could say that the type of car purchased would be a reasonable predictor on the age category of the person that the car belongs to. Okay, and we're done. Hopefully that gives you a bit of confidence with different types of questions on bivariate data that you might experience in internal or external assessment in an exam situation, and you've got a bit more confidence about doing those types of questions.